Today we're going to learn our first sorting algorithm, selection sort. I'm going to start by what's sorted and what isn't. Alright, so this is sorted. It is in a line and they are ordered from shortest to tallest. We are always going to make them from least to greatest. Alright, here we have a line, but it isn't in any order, so it is not sorted. This is a line and it is in order, so it is sorted. This has no line, no order, not sorted at all. Line, in order, sorted. This is what they call sorting in kindergarten and in grade 1. This is not what computer scientists call sorting. This is like random groups of beads or something. I don't know. Not sorting because there's no line. Okay, so when we're putting things in sorted order, we're going to be using comparing functions. And what we're going to be doing, if we have a chart enter double, is we're going to be comparing, like, if x is smaller than y, we'll do something. And if x is bigger than y, we might do something else. And if x equals y, something else. Yeah, this is how we normally compare things. With strings, though, something I'm going to point out to you now is that if I wanted to do x is less than y, if x and y are strings, I write it like this. This causes students panic for reasons I've never understood, but if you want a string, you put the x there, the y there, and if you want it less than, you put a less than there. Okay. I actually wrote this on the wall in our classroom, so you could have looked there should we have been in the classroom. And then equals is dot equals. So why do we sort? Well, we sort because it's much easier to find things in a sorted list. So if we want to find out where Kent is, it's super fast to find him in the sorted list. You just go right to the spot. That's why telephone directories, dictionaries, book indices, all that stuff, they use alphabetical order. It saves us huge amounts of time. If you have 100 things and they're sorted, it takes you a maximum of 7 searches to find them. Whereas if they were unsorted, you'd have to look at all 100 of them. So another reason why it's useful is that once they're sorted, the extreme cases are really easy to find because they're at the beginning and the end. Those are the mins and maxes. That's useful in insurance. Let's say, for example, my sister says that the cases that are like, there might be one case that's $3 billion and everything else is in the thousands, but that one case that's at $3 billion is going to mess up everything. So you really need to know those outliers. Another thing that's good about sorting is it allows you to find duplicates, and they're easy to find because they end up together. Computer scientists spend a lot of time putting things into order. You think about Netflix, your computer's going to get, I don't know, thousands, millions of packets when you're watching a video, and your computer has to put those packets into order. They come in a random order into your computer, and so your computer actually sorts them and then displays the movie in order so that you can understand it. All internet stuff has packets that need to be placed into order, so you can see how very important that is. But like we do stuff in Excel, we sort things, in databases we sort things, like your posts in some form of social media are going to be sorted by date, all that kind of stuff. Because we sort all the time, it's really important that we find efficient sorting algorithms so that things go really quickly. Remember, the efficient algorithm could run even on bad hardware, and the really inefficient algorithm, it didn't matter how good the hardware was. So computer scientists want to spend a lot of time getting it right. So we're going to start with selection sort. But first we need to learn how to swap. So a swap is like this. We have a thing here and a thing here, and we end up with them swapped position. So here is what students like to do when they're coding this. They're like, swap is 2 steps. We take one thing and put it in the other, and there we go. So what happens in this code is we take the thing in position 1 and we place it into 0. So the thing in position 1 gets placed into 0. I suspect you see our problem. Then on the next line, what we do is we take the thing in position 0 and we put it into 1. So we take the thing in position 0 and we put it into 1. Yeah. We lost the 67. So the way a swap actually works is a swap is always 3 lines of code. And the first line of code is where we store the temporary variable. So what we're going to do is we're going to take 0 and store it in temp. So we take 0 and we store it in temp. Then on the next line, we take 1 and store it in 0. So we take the 1 and we store it in 0. Then on the last line, we take the temp and put it into 1. So the temp and put it into 1. And those are the 3 lines to make a swap. Don't try to do it in 2. You can't. Okay. Another thing about swap, which I'll say just quickly, is that this is 3 lines of code. There are no loops, so swap is a constant time and order 1 algorithm. So let's trace selection sort. Let's say that this is our array. What we're going to want when we have selection sort is we're going to want the small numbers down here and the big numbers up here. And we're going to want them in order. So with selection sort, what we do is we find the biggest thing, and the biggest thing is 8. Then we're going to swap 8 into its correct location, and so we'll swap it with 2. Okay, now what happens is 8's in place, so we're going to find the next biggest thing, and that's 7. Then what we're going to do is we're going to swap it into its location. Then we're going to find the next biggest thing, and the next biggest thing is 6, so we swap it with 1. The next biggest thing is 4. We swap it with 2. The next biggest thing is 3. The next biggest thing is a 2. The next biggest thing is a 1. And then it's in sorted order. Selection sort always has this nice pattern where we've got all this sorted section at the end making a little ladder at the end. We're always going to sort the maximum into place. So one of the reasons I've shown this to you now is because you know how to find the maximum, so we're going to have that in our code. There's an important application of selection sort. When you were a little kid and you had a big bag of Halloween candy, you used to put it in sorted order. You were one of 2 kinds of kids. You might have been the kind of kid who puts it in order from the best candy to the worst candy, and then you eat the best candy, then you eat the second best candy, then you eat the third best candy, all the way down to the dregs at the end. Or you would have been the other kind of kid who sorted it from worst to best, and you would have eaten the worst candy and then the second worst candy and so on up to the best candy. That is selection sort in a nutshell. Pick the best thing and then carry on down the list. So here's the selection sort card. We're going to repeatedly find the largest number and swap it into its correct location. It's order n squared. We're going to take a look at the code in a minute. There's 2 loops. There's no best case. That's something that will become relevant tomorrow. It works. It's a general case algorithm as well. It works for all kinds of data. You might have to recode it ever so slightly, but it can be coded for strings and chars and doubles. Okay. So another concept that's really important with sorting is you're going to see that there is no one best sorting algorithm that works in all cases. We always have a trade-off and we have considerations to choose from amongst them. In grade 12, we basically add more sorting algorithms, which just adds more trade-offs that we choose between them. So the thing about selection sort that's really good is it's really simple to understand and it's really simple to code. But because it is so simple, it isn't very clever and it isn't very efficient, and that is what makes it slow. So if I have a very small data set, I might use selection sort because it won't matter quite that much. If n isn't big, it doesn't really matter that much. And the simplicity might be important to me. However, if I have a million elements, I'm sure as heck not going to use selection sort. I made a video on YouTube showing you how to trace it on a piece of paper, so you might want to take a look at that just to get another example. So let's take a look at the code. And we're going to translate it to English. Let's start with the line in pink. That is the line where we declare our array. Then let's take a look at the kind of the neon green stuff here. Int max, if the max is less than the spot, max equals I. Well, we're finding the maximum there. Yeah? That's our max code that we've made a million times. Okay, let's take a look at this blue code here. This blue code, we've got a temp, we've got some, this is the swap. This is swap going on. So what's actually happening in the code is we're finding the max and we're swapping it into place. Then this other loop is basically saying for the non-sorted part of the array, keep finding that maximum and putting it into place. And then we move it a bit smaller, and then find the maximum and put it into place, and then move a bit smaller, and so on. So this code has a nested loop. It has a loop out here, that's n, and then it has another loop here, that's also n. So we have n times n is an n squared algorithm. Okay, good luck with your sheet.